Hi, it's Charlie Zeiss with Stargate Pyramids and the Pyramid Science Foundation. Today's video is going to be about the 3D phi scaling geometry in hypersonic vehicles. We've done a lot of information previously about jet aircraft and rocket ships and so forth, but I didn't ever expand that original research into hypersonic vehicles. And so I wanted to do that today because not only do they continue to demonstrate the significance of the 76.345 geometry, but it also proves how important it is in very, very high-speed travel. So two of the things that really become problematic when you start to do hypersonic speeds, and by the way, a hypersonic definition is anything over 5 times the speed of sound. So that's when you get into the hypersonic world. But anyway, those two factors are, number one, geometry is critical in achieving these very, very high speeds. You want to have as little wind resistance as possible. And kind of a secondary outgrowth of friction and wind resistance issues is the fact that if you don't have your geometry right, it's going to be virtually impossible to keep these structures viable because of the heat that they're going to generate going through the atmosphere at these rapid speeds. So you've got really two things here that are exacerbated by geometry, and 76.345 seems to be at least the best solution to both of those issues when it comes to hypersonic travel. So you probably heard a lot about hypersonics because the Russians are the world leaders at this point in hypersonic technology. They have developed hypersonic weapons, which even our own military admits we are incapable of stopping. So we are kind of the laggards of the big three. China is moving forward in this as well. We're kind of coming in third place at the moment, and I know we're going to be investing a lot of money into this kind of technology. But the Russians already have this technology functioning. One of their they have three basic systems. One can be launched from ships or submarines, another can be launched from aircraft, and the others can be launched from a ground-based ICBM rocket, which will propel it up to the upper atmospheres, and then it'll take over from there. So I thought what I'd do first is just show you three examples of the Russian technology, because it's the one that we know works, and show you how those actually look. So I'm going to open up my slide presentation now. And here we've got two examples of Russian technology on the front page, which we're going to go through right now. Now, this particular, let's go to slideshow mode here, and we'll go back to the beginning. Okay, when we start to look at the air launch systems that Russia has put together, these are called the Kinzhal units. This is a military aircraft from Russia, and of course its nose cone has this geometry as well as the missile that it's carrying. But I wanted to show you up front here, and you're going to see this in all of these. I have for this video, I'm not using the 76.345 base angle, but I'm using the 27.309 apex angle because it turns out it's easier to measure with this type of equipment that we're looking at today. But that's why we're using 27.309. We can see that it's in the nose cone of the jet aircraft that is using it. We knew that from before, but then when we go on and look at the nose cone of the actual hypersonic vehicle itself, a rocket, this is what we're going to see. And once again, we see the 27.309 geometry. Now, this is a similar type of device this is called the DF-17, and this is what's called a hypersonic glide vehicle, or an HGV. We'll see the Russian equivalents of that in a minute, but this one is from China, and you can see the picture on the left here. This is actually a scale model inside of a wind tunnel. They're doing wind tunnel testing on it. And we can also see the geometry here where that scale model is being held by a couple of the engineers. And we're able to measure it as well. So we see this geometry. And again, the reason why you see it is because it's the one that's going to cut down the most on turbulence and resistance. And therefore, it's going to minimize the heat buildup on the model itself. Now, here's another example of HGV technology that's being put together by India. India is a couple of years behind Russia and China, but they're supposed to have a Mach 6 version of this ready to go by as soon as 2025. So they are very much, in this along with the other major players around the world. Now, here's an example of a USA version of a hypersonic glide vehicle, or HGV. This one's called the Falcon HGV 2 from the United States. I've got two pictures here, the same ones. You can see that there is an indentation on each side here, and that's where we see the 27309 geometry is there. These sort of tend to, beyond that starts to flatten out and sort of become like a wing for this device. One of the key things to know as well is that all of these hypersonic glide vehicles have the ability to navigate, to go up and down, to the right and to the left and so forth, just like a ship. Then that's what distinguishes an HGV from, say, a missile, which can only really fly in one direction. So anyway, that's what makes, in addition to the speed, that's what makes these so difficult to lock onto and to destroy from any sort of defense system that you might try to put up against it. And here's another example. This is, examples. This is kind of a more up-to-date version of that Falcon HGV 2. You can see here, and again, you see this geometry, and then you see these essentially the wing component, beyond that point. So you're seeing that geometry here. Here was an interest. I was watching a video about HGVs, and I saw these spirals. Essentially, these were coming out of a wind test tunnel, and so I decided to measure them. And sure enough, these spiral rings that are coming out of the wind tunnel testing seem to be using this producing this 27309 geometry. So fascinating information. And then here, this is one that I had previously seen, but I found an updated photo of it. This is the Lockheed Martin SR-72. It's a hypersonic vehicle that Lockheed Martin is developing here in the United States. It's gone through numerous iterations. It's, I believe, now in a more of a drone configuration, meaning there won't be pilots in these aircraft, but that this will be an unmanned craft when it's put into operation. Now, here is a picture of what are called scramjet engines. The normal jet engines that we use to power our current commercial airliners and jet aircraft and so forth, because they generally don't, those types of jet engines can only get up to about Mach 3, at which point there's a newer technology called a ramjet engine, which will take you up to speeds of about Mach 6. which is 6 times over the speed of sound. But beyond that, the newest technology is what's called a scramjet engine. And that scramjet engine will get upwards to Mach 20, which is what the Russians say they're capable of getting with their technology. So this is a picture of what's called a Sabre system, synergetic air-breathing rocket engine. Essentially, air at that speed is sucked in so quickly that it can be concentrated and pressurized through the proper use of geometry, as it turns out. And then when the fuel is ignited, it's pushed through the nozzle here at the back. And sure enough, that nozzle contains the 76345 geometry. So we found it there. Now here's a simplistic diagram of scramjet engines. On the left, we see the blue or cooler air coming in. It's being sucked in and compressed, as you can see, through this conical structure, which heats it up and makes for a better ignition here inside in the central component. And as the air is being pushed through and it ignites, they're using geometry. Once again, you'll see on this backside, this is where the propulsion is coming out of the back of the rocket. We're seeing that 27309 apex angle geometry once again showing up in this diagram of a scramjet engine. Now let's look at a couple of the SpaceX engines, and we'll see that this geometry is found in these as well. This is the earlier engine that SpaceX developed called the Merlin Engine, and we can see that geometry here inside of the expulsion component of the rocket, of the engine. And here are some more up-to-date Raptor engines, and we can see this geometry at work in those engines as well. So Elon Musk knows about this from a variety of different perspectives. We've seen this in other videos. It's actually the 76345 geometry shows up in the Tesla Motors logo, in fact. So anyway, there's a number of these, obviously. So we know that this is important to hypersonics, and that's the reason we're finding it there. I hope you found this interesting. It proves once again that this geometry is critical to the geometry of phi scaling to creating the abilities of these amazing hypersonic vehicles. So I thank you for listening. Again, we are having a sale on all of our pyramids at stargatepyramids.com. If you use logo 30 and go to stargatepyramids.com, you can get 30% off of all of our pyramid products. If you're interested in talking to me, please feel free to contact me at charlie@stargatepyramids.com or at my phone number 412-474-3481. And as always, I want to thank you for watching, and you have a great day.